Imagine a world where machines think entirely on their own, without needing an internet connection. A brand new microchip has just arrived and it will change human history forever. Today, this processor holds the exact same power as a massively expensive $30,000 computer. Yet it consumes a tiny fraction of electricity and fits perfectly inside a humanoid robot. Surprisingly, the company decided to skip cars entirely and put this technology directly into robots. Why would anyone prioritize a walking machine over the highly popular autonomous electric driving vehicle? Because this machine self-learns from over 8 billion miles of intense real-world driving. It can handle absolutely every unpredictable situation completely on its own, without using any cloud. The production line is already preparing to build 1 million of these mechanical workers annually. Is this truly the most massive technological upgrade in the entire history of global robotics? To understand why this massive shift matters, we must first talk about the semiconductor industry. In this specific world, there is a point of no return, strictly known as tape-out. This happens when a finished chip design goes directly to the physical manufacturing fabrication plant. After this crucial moment passes, engineers can no longer make any revisions or further changes. This incredibly powerful new processor has just passed this exact milestone and is now real. Mass production is about to start at the most advanced semiconductor facilities in the world. Giant manufacturing plants in Texas and Arizona will handle the heavy lifting for this production. Furthermore, a dedicated $20 billion processor factory is currently being built in Austin today. But the biggest surprise was never the actual creation of this incredibly advanced silicon chip. The true shock came when people finally learned where this specific processor is going first. It will not power the highly anticipated cyber taxi or the upcoming self-driving cars. Instead, all priority goes directly to the third generation of an ambitious new humanoid robot. The creator once famously stated this walking machine would become their most valuable product ever. This bold strategy also includes a massive promise to manufacture 1 million units every year. To truly grasp why robots come before cars, we must examine past failures in robotics. Traditional intelligent machines hide a very harsh reality that almost nobody wants to openly admit. The simple truth is that they are practically useless when operating entirely on their own. Most modern mechanical workers rely heavily on a massive server running somewhere in the cloud. They constantly gather vast amounts of local data and quickly transmit it to central computers. Those external servers process everything and then send strict commands back to the mechanical body. This system works perfectly until the local network connection suddenly becomes slow or completely drops. If a factory router fails, these highly expensive machines instantly become frozen blocks of metal. In any serious industrial manufacturing setting, this kind of operational failure is completely unacceptable today. An entire assembly line stopping because of a dropped signal wastes thousands of dollars hourly. However, there is a second major challenge making building autonomous machines incredibly difficult right now. That massive hurdle is the shocking amount of electrical power required for complex real-time thinking. Today's most powerful processing units consume more than 500 watts of electricity continuously running. These expensive computer parts also cost roughly $30,000 for just a single unit. A standard robotic battery only holds enough power to provide 2 or 3 kilowatt hours. If the brain uses 500 watts alone, the battery rapidly drains in under 6 hours. This calculation entirely ignores the power needed for heavy motors and all the required sensors. Practically speaking, this machine would only survive a few short hours before completely shutting down. That is exactly why nobody has successfully built a truly independent worker at industrial scale. The global industry never lacked brilliant ideas, but the physical hardware problem seemed completely impossible. Now, it seems someone has finally engineered the exact breakthrough heavily needed to solve this. The latest microchip generation represents a massive leap forward from the older vehicle-based processors. The computing performance is exactly 8 times stronger than what current electric vehicles use daily. The internal memory capacity has increased 9 times, allowing for vastly superior real-time data handling. Furthermore, the overall data bandwidth operates exactly 5 times faster than the previous hardware generation. This single small processor delivers the exact same output as massive industry-standard graphics cards, but consumes only 250 watts, which is half of what older technology draws. 250 watts is the magic number that suddenly changes everything about modern robotics. At this low power level, the machine can operate through an entire factory work shift. Because all processing happens physically inside the chest, it never needs external data transfer again. Every single complex decision gets finalized instantly, completely ignoring whether wireless internet exists or fails. This means the robot holds enough local intelligence to flawlessly continue working during network outages. It perfectly mirrors how current self-driving vehicles navigate busy city streets without cellular data. What truly makes this hardware special goes far beyond those highly impressive performance spec numbers. The secret lies deeply within the unique design philosophy guiding this entire complex engineering project. Most competing chips must carefully serve countless different clients across many wildly different computing tasks. Because they remain highly flexible, they contain dozens of unnecessary internal components wasting valuable energy. Engineers ruthlessly stripped away every single traditional graphics processing unit and standalone image signal module. They completely dedicated the remaining silicon area specifically toward running complex neural networks incredibly fast. This perfectly mirrors how leading computer brands drastically improved laptop battery life using custom silicon. Applying this exact mindset to mechanical workers created something incredibly powerful yet wonderfully cost-effective. The resulting hardware costs almost nothing to produce but confidently replaces outrageously expensive server equipment. Furthermore, this physical machine does not rely on traditional laboratories to learn basic movement skills. It never requires thousands of brilliant software engineers painstakingly writing code for every individual joint. Instead, it uniquely absorbs knowledge directly from immense visual datasets that rivals simply cannot access. Long before this metalworker ever took its very first step inside a manufacturing plant, it had already studied millions of miles of complex driving footage gathered from electric vehicles. More than 8 billion miles of unpredictable human driving scenarios deeply shaped its artificial brain. The system witnessed heavy rainstorms, completely dark nights, crowded highways, and incredibly dangerous unexpected obstacles. All this recorded chaos actively fed the main neural network, building an unbreakable learning foundation. This specific competitive advantage remains completely impossible for rival companies to ever purchase with money. Legendary robotics companies have proudly existed for nearly 3 decades without reaching this massive scale. Those ambitious startup companies must slowly build their entire training catalogs entirely from absolute scratch. Meanwhile, this groundbreaking project confidently starts the grueling race with billions of perfectly recorded miles. However, road footage only provides basic vision, while humanoid workers desperately need perfectly functioning hands. Vehicles never grab objects, so engineers needed an entirely new method to teach physical manipulation. They solved this complex dilemma by sending camera crews directly onto active factory assembly lines. These observers never wrote rigid programming code, they just quietly filmed real humans doing jobs. The system carefully watched how human fingers gently grep tiny metallic components without dropping them. It learned how human bodies naturally shift weight backward while carrying extremely heavy industrial materials. The cameras captured how human eyes constantly scan tight physical spaces before safely stepping inside. All these wonderfully natural human behaviors quickly became vital lessons for the artificial machine brain. The humanoid simply learns by watching, much like a silent toddler naturally figuring out walking. Engineers eagerly want to push this observational learning magic even further into the digital future. Soon, they hope the machine can simply watch random online tutorial videos to master tasks. Showing an ordinary assembly video might automatically grant the robot full comprehension of complex procedures. While still actively under development, this audacious goal loudly signals massive long-term corporate ambition. Surprisingly, none of these brilliant learning methods represent the absolute peak of this technological marvel. The most terrifyingly impressive aspect involves secret training happening deep inside a completely simulated universe. Developers constructed a highly advanced digital reality entirely powered by deeply intelligent neural network systems. This digital world greatly differs from those basic environments typically seen inside modern video games. Standard software uses rigid mathematics and hard-coded physics to render predictable three-dimensional spaces. This unique simulator magically generates hyper-realistic scenarios based completely on actual recorded physical footage. It endlessly creates perfectly shifting shadows, randomly falling objects, and chaotic events nobody could predict. Inside this matrix, the virtual machine repeatedly trains itself across tens of thousands of scenarios. It violently fails, instantly analyzes every tiny mistake, and immediately attempts the exact challenge again. This hyper-accelerated virtual practice perfectly guarantees zero physical damage and absolutely no financial risk. We must now examine the single greatest operational advantage keeping this fierce robotic competition terrified. Industry insiders fondly call this unstoppable data-gathering mechanism the legendary mechanical fleet training flywheel. The core mechanism sounds wonderfully straightforward when explained in very simple, everyday, conversational English terms. Every single working machine constantly records high-definition video data from its immediate physical environment. This fresh data rapidly flows directly into massive centralized computer servers for immediate deep analysis. Powerful algorithms extract brilliant new lessons and securely package them into tiny software update files. These vital digital upgrades then magically beam down to every other machine wirelessly through networks. It perfectly copies the exact same seamless wireless update system that modern electric vehicles utilize. If one lonely robot accidentally discovers a brilliantly clever solution to a strangely difficult problem, within several hours, the entire global workforce inherently understands exactly how to solve that puzzle. As the physical workforce rapidly expands toward 1 million units, the collective intelligence absolutely skyrockets. This exponential brain growth totally outpaces anything competing robotics laboratories can possibly hope to match. Running this massive learning loop strongly requires two incredibly crucial technical elements functioning perfectly together. You need brutally powerful internal processors and an army large enough to harvest diverse experiences. Right now, engineers are furiously building both of these monumental technological pillars simultaneously in parallel. The terrifying reality for competitors is how fiercely this data advantage heavily compounds over time. Manufacturing more physical robots naturally generates vastly larger amounts of highly valuable training video data. Feeding more complex data into the digital brain directly creates vastly superior artificial intelligence models. Smarter artificial intelligence inevitably means these mechanical workers confidently perform significantly more highly complex jobs. When machines easily accomplish harder jobs, eager corporate customers immediately purchase significantly more metallic workers. This endless cycle aggressively spins forward, constantly widening the painful gap separating winners from losers. However, ignoring the obvious corporate blind spots would absolutely ruin this purely objective technological analysis. We must speak plainly about the harsh reality constantly hiding behind those glamorous press releases. A shockingly massive gap continually exists between future product announcements and currently existing factory realities. Company leadership fully admitted that current walking machines primarily exist just to awkwardly gather data. These early prototypes absolutely cannot generate any seriously meaningful economic value inside factories right now. Engineers openly classify this entire ambitious project as strictly an ongoing research and development phase. The media often blindly assumes 1 million robots automatically equals 1 million perfect human replacements. The cold truth simply means factories will successfully manufacture 1 million empty metal bodies annually. Predicting their actual physical clumsiness or ultimate professional competence remains an entirely different speculative debate. Secondly, this miraculous new microchip will certainly not power these walking frames anytime very soon. The final hardware designs only recently reached completion, meaning physical samples remain many months away. Therefore, every single prototype currently stumbling around test labs definitely runs on vastly inferior hardware. Massively deploying this revolutionary silicon brain into public factories truly belongs to a distant timeline. Being incredibly excited about future processor generations feels perfectly natural for passionate technology enthusiast communities. But separating today's clunky reality from tomorrow's promised mechanical utopia absolutely demands strict mental discipline. Finally, we cannot possibly ignore the incredibly fierce global competition desperately chasing this exact dream. Famous legacy companies boast over 30 long years of brilliant physical robotics engineering design experience. Other aggressive startups happily enjoy massive billions in funding from leading artificial intelligence software giants. Some incredibly agile engineering teams already signed massive commercial contracts to stock massive corporate warehouses. Meanwhile, foreign competitors aggressively manufacture highly capable humanoid frames for practically nothing in material costs. They eagerly sell walking hardware for prices drastically below this heavily hyped 20,000 target. These hungry rivals completely lack those legendary 8 billion miles of recorded automotive driving data. They also desperately miss the compounding learning magic generated by that previously discussed fleet flywheel. However, they command immense advantages regarding manufacturing costs and shockingly fast commercial market retail deployments. Ordinary industrial consumers typically care deeply about upfront financial costs and immediate practical physical availability. This company clearly chooses to patiently play an incredibly slow but highly rewarding long game. Will the notoriously impatient global market actually wait years for this ultimate perfect mechanical worker? Could these highly motivated competitors miraculously discover unexpected new shortcuts to suddenly close this gap? Reviewing everything objectively, that massive data flywheel constantly feels like the only truly untouchable moat. Innovative processor architecture regularly gets cleanly reverse-engineered by equally brilliant rival international engineering teams. Sleek physical joint designs constantly get perfectly copied and slowly improved upon by hungry competitors. But massive mountains of complex behavioral video strictly require countless decades to organically, naturally accumulate. Combining that history with millions of robots learning simultaneously forever feels genuinely impossible to copy. Nobody can magically purchase 30 years of simulated physical experience overnight with pure venture capital. This heavily guarded secret totally explains the shocking decision prioritizing walking machines over driving vehicles. Current generation electric vehicles already drive wonderfully using older but highly capable, reliable silicon brains. They literally need this new massive processing power strictly to awake the mechanical worker army. Every single wasted month directly prevents that beautiful data flywheel from finally spinning at maximum. Once this brilliant autonomous learning cycle violently accelerates, absolutely nobody will hold power to intervene. Millions of bodies endlessly thinking using brains completely rivaling outrageously expensive professional studio graphics cards. Everything we just explored actively happens right now outside the magical realm of science fiction. This overwhelming technological revolution angrily knocks upon our collective front doors at this exact moment. Ensure you carefully study these profound changes before the modern digital economy permanently leaves you. We constantly face an incredibly unpredictable digital tomorrow demanding our absolute, full, unwavering mental attention. These deeply powerful processors actively represent the beating mechanical heart of our completely rewritten future. Humanity suddenly stands right upon the incredibly thin dividing line separating past struggles from tomorrow. Artificial intelligence continually proves it will aggressively physically manifest into our strangely evolving physical reality. The silent metallic workforce simply waits for perfectly crafted silicon brains to slowly wake up. Soon enough, humans might peacefully walk alongside infinitely intelligent creations during normal afternoon grocery trips. Massive automated warehouses will operate entirely darkly without needing any expensive traditional overhead electrical lighting. Every single exhausting manual labor job could cleanly vanish from human history within 1 decade. But we strictly remember that building paradise inevitably involves crushing delays and extremely painful failures. We must relentlessly watch how quickly rival corporations desperately try closing this supposedly invincible moat. Perhaps someone cleverly invents drastically better training code, perfectly replacing those missing 8 billion miles. Until that unpredictable day inevitably arrives, this specific company confidently holds the ultimate technological crown. The mechanical brain perfectly exists right now inside heavily guarded secret underground research facility laboratories. The required body frames continuously roll straight off rapidly advancing high-speed modern assembly lines. When those two separate pieces finally merge together, our fragile world forever profoundly, fundamentally changes. This fascinating ongoing journey totally demands our undivided attention as the impossible smoothly becomes real. Keep constantly asking brilliant questions regarding where this beautiful, dangerous silicon pathway inevitably leads humanity.